Let's say that we want to transfer a text from one computer to another computer, but the computer does not understand the text, the simple text. So for a computer, we need to transfer that text into a binary and then send over the wire. So the process of converting a text into a binary is called encoding, and the reverse process of let's say we have received a binary in another computer and we want to convert that, we want to convert it to text, that process is called decoding. So in our case, what will happen is when we are sending a hello world, in reality what will happen, H will be transferred to a binary to 72 in decimal, and then binary 0100 and the 100, and the E will be transferred to also E and L will be transferred to binary and will send over the wire to another computer. But how do we know that which letter or which digit is correspond to which letter, which digit is correspond to which binary number, and which lowercase letter correspond, lowercase or uppercase letter correspond to which binary number? So for that we are using a standards. One of the standard is ASCII. In the ASCII what we have is we have for the digit 0, right? So digit 0 is represented in decimal as 48, and we are sending a binary representation of 48. If we want to send the digit 0, the same way we are for the lowercase a, if we want to send the lowercase a, b, we are sending a 97 in decimal, not the 97 decimal, but we are sending a binary representation of the 97 and 98 and so on. So in ASCII, in ASCII standard, we have one character is equals to 1 byte. So which means that it only covers 128 characters. So which means that we have only 128 variations, right? So we have a lowercase, uppercase, and we have digits and so on. So what happens if we want to, let's say, well, if we want to send text in another language, in another alphabet? So ASCII can't encode, decode Japanese, Hindi, Chinese, and some European characters. So for that, to solve that problem, what we do is we have a universal standard that was introduced, which is called the Unicode. In the Unicode, what we do, we assign a unique number called the code point to every character in every language on Earth, to every language, to every alphabet. We are assigning a unique code point. So in Unicode, instead of having for one character having a 1 byte, we have 4 bytes. So which covers that, which is the 32 bits, which for the 32 bits, it covers 1.1 million characters. And for example, let's say that the uppercase A is U plus 0041 in Unicode, and the same for the Japanese characters and Chinese characters. They have their own unique code point. So what is the meaning of the U plus 0041, right? So U means that just the Unicode, and the plus is the separator. It means that the following is the number for this character, and the 0041 is the actual code point. So if we go and see that what is exactly is U plus 0041 means, it means that in the decimal it means 65. It's a Latin capital letter A, and the 97 is the Latin small letter a. So as we can see here, the first 28 characters in the Unicode also corresponds to the ASCII, right? They are interchangeable. So which means that whatever we have in ASCII, let's say that the digit 0 is 48, right? It will be the same in the Unicode. And for the following characters, we have the characters in other languages, characters in other languages and other alphabets and so on. So we even have the Unicode for the emojis. For example, a grinning face, it has its own Unicode code point, and the red heart, rocket, and all others emojis have their own unique code points. Unicode is just an idea. What's the standard that we are using for the Unicode? The one standard that we are using is Unicode Transformation Formats, or short UTF. So we have a different variation of the UTF. The first one is that the UTF-32. It uses 4 bytes or 32 bits for every character. It's simple, but it's wasteful because, for example, even for the uppercase it will take 4 bytes. Another one that we have is UTF-16. It uses from 2 to 4 bytes per character. It's more efficient, but it can get tricky when mixing languages. And the de facto standard that we have is UTF-8. It's the most popular. It uses from 1 to 4 bytes per character, and it's backward compatible with ASCII. So what's that mean? For example, let's say that we want to transfer hello world in UTF-8. So it will take just a 1 byte per character for the hello world. But if we are going to transfer in Japanese characters, it will take 3 bytes for each character. That's about sending the text over the wire. But let's say we want to send an image or we want to send a video over the wire. So let's say that we are sending 1-to-1 pixel PNG as an attachment to an email, or let's say we are sending HTTP request, and in the body of that HTTP request we are sending a PNG image. So what's the PNG image? PNG image is just the collection of bytes, and if we want to transfer that as a part of our text, so what we need to do first, we need to convert that into the text. Why we are doing that? Because otherwise it will corrupt our UTF-8 or whatever standard that we are using. It will corrupt the encoding and decoding for that standard. So for that, what we do is we are using another encoding standard, which is the Base64. Base64 is why it's Base64? Because we are using only 64 characters from A to Z, or from uppercase or lowercase, or digits from 0 to 9 plus and the backslash. So the only 64 characters we are using in order to encode Base64 encode binary into a text. So we are Base64 encoding binary to text, and then when the message is received, we are Base64 decoding those characters into the binary in order to show the image. So Base64 is not meant for the hiding or encrypting data. It's just repackaging binary as a text. So what in reality happens is when we are sending a 1-to-1 pixel PNG, when we are sending as a binary, first thing that we do, we are Base64 encoding that. Now we have the text representation of that message that we can safely send over the wire. But we are not just sending, but we cannot send the text, right? So for that, what we need to do is we need to again Base64. We need to ASCII or UTF-8 or whatever standard we are using to encode that. So actually, when we are sending an image over the wire as a part of the, let's say, JSON, or as an attachment, what we do is we are encoding that twice. First, we are taking that binary and we are Base64 encoding that into the text, and then we are taking that text and we are encoding that into a binary and sending that over the wire. Let's take this example. Let's say that we are sending HTTP request, post request, uploading an image, and we are sending a JSON that contains an image and that contains a username, right? The username is Orkan, and the image that we want to upload. So what we do first thing is we are Base64 encoding our image into a text that we can safely transfer to another computer. So, and another step is that what we do is we are taking that every piece of that HTTP message, including the request line, the header, and the body of that message, and then we are UTF-8 encoding that into bytes, and then we are sending. So to sum up, so what we do when we are sending an HTTP request for the raw HTTP text, what we do is if that HTTP contains any image or video, then we are Base64 encoding that. And after encoding that, then we are UTF-8 encoding that into the bytes. And then we are encrypting that, right? Because we are sending usually HTTPS, which should be secure. So we are TLS encrypting that into the ciphertext, and we are transmitting that over a cable or over a satellite. And then when we receive that message, what we do, we are TLS decrypting that into the bytes, and we are UTF-8 decoding that. And if that message contains video or image, then we are Base64 decoding that, and then we are showing the result of the HTTP text.